Hello, how y'all doing today? My name is Bernie Thompson, and today we're here to take a look at this 2016 Kia Rio. This Kia has a problem where it's setting a DTC for the high pressure fuel system. The shop that brought this car to this shop has already put a computer and a high pressure fuel pump on it trying to fix this problem. Now we need to properly diagnose this vehicle, so the first thing I want to do is get a scan tool and gather some basic data so we can make a diagnostic decision. Okay guys, I got the scan tool up. Let's go ahead and get some basic information. So basically I have good fuel control. I am stoichiometric. The long-term and total trim are good. The vacuum on the motor is good. We have 2 pending codes set, and we haven't run our monitors, but that's because they've cleared the codes. They've been trying to fix this car. So let's look at the codes. So basically I've got a fuel pressure sensor is low input. Now the fuel rail pressure sensor performance range problem, this is the code they've been trying to fix. He didn't tell me that it had a low input. He said we had a range or performance problem, and he thought that this might be being caused by the camshaft timing. I've seen a few of these where the cam's out of time and it doesn't set a cam code, but then the pump is out of time from the system. Now we need to figure out what's going on, but that was just what the shop had thought that he wanted me to sort of check. So that's the code we're looking for. So now let's go ahead and get some PIDs. I want to pick the rail pressure sensor. I want that one of my pieces. We'll put him up here. So now this is in HG, so you divide that in half for PSI. The conversion factor is 2.036. So you just basically divide that in half, and that will give you your PSI. So we can see that we definitely can get up to a couple of thousand HG. That'd be like 1,000 pounds of pressure just sitting here revving it. So right now it seems good, the engine sounds good. So this is my pressure, this is my fuel trim, and this is short, this is long. So these are the main ones I want to look at. So if this pressure drops, I have to trim as well. The other thing I want is we're going to change the RPM. I want the lambda. So I've got a lambda of 1. And if that pressure drops, the lambda is going to go up high and the trim is going to take care of it. That would prove we really have a fuel pressure problem. Like the shop that originally had this car, that's what they've been trying to fix. They put a new fuel pump and a computer on this car for this problem. So now we need to just make sure what we're going to put on is going to fix the car. So we're going to properly diagnose it. So we need to drive the car so we can see what we've got. So it pulls pretty good. We're 4,300 pounds, or 4,300 HG. So that's basically 2150, something like that, on pounds of pressure, and the car pulled good. I didn't feel any kind of a problem. Again, we've got 4,200, and we have no fuel trims occurring, and I've still got a lambda that's okay. Now right there I've got a lambda that's lean because we're in a fuel cut because I got out of it. Right there, the car just totally failed. Did you see that drop? The pressure dropped to almost nothing. But my fuel trim did not come up and my lambda stayed okay. So let's see what we can do. So I want to see that again. We're going to watch the pressure. That's in the yellow up in the corner. I'm going to get in it. We're pulling strong. It just totally cut out 35 Hg. That's no pressure at all. My fuel trim is only at 23 and my lambda is lean, but that's because I let off the throttle because it was cutting out, so it went into a lean cut. Right now I have lambda. Let's do this a little bit different now. Okay guys, so what it appears is when I get in it hard, I'm losing fuel pressure. So let's go ahead and check this. And it's what I want to see the fuel pressure fall, and I want to see a bunch of trim come in, and I want to see the lambda go lean. That proves that I lost fuel pressure. I'm trying to figure out, because that had a low output, like something might be wrong with the wiring or the sensor. So I'm just trying to see if this might be a real problem with the high pressure pump, or it's just a sensor failure. And I don't know you can do that without a scope, but we're going to try to just see what we can do with the scan tool. So we're going to just get in it a little bit. We've got good pressure. I'm going to floor it now. Now we got a lot of pressure cut out, 67 Hg. I went up to 23% on the trim. My lambda still 1. My pressure returned. So now let's go back over here and look at the graph. So now we can see where I got up to about 4,000 Hg pressure, and then we just dropped almost nothing, and then as soon as I got off, it recovers. Now the trim gained about 20%. Long term stepped up some too, but it stepped up earlier than I lost pressure. Short term tried to correct that problem, and we can see that the lambda went from 1 to 2, so it definitely went lean. That definitely didn't get fuel to the engine. So that definitely makes me think one way or another, I'm losing pressure. I'm not sure right now, but I know I need to get a scope on this car. So we're going to go ahead and get a scope set up on the car and get some more signals so I can figure out what's wrong with the car, what's happening. So let's go ahead and get that scope connected. Okay guys, I got the scope connected. Let's take a look at where I've connected to. I've got channel 1 in yellow on the high pressure rail sensor output. I've got channel 2 in red on the 5-volt input to the sensor. If I've got a low voltage code, I'm figuring either my output is bad or my 5-volt in is bad, so those are the two things I want to watch. Channel 3 green, I've got an amp clamp on the high pressure regulator. Channel 4 blue is on the number 1 ignition coil. Then I've got channel 5 white and channel 6 purple. Those are reading the voltage that controls the high pressure regulator. And then I've got channel 7 and 8, that's orange and brown. That's the number 1 fuel injector. Let's go ahead and get the data and go for a drive. Let's figure out what's wrong with this beast. Okay, I have the scope connected. Let's go ahead and set the scope up. On channel 3 I have an amp clamp. I want to zero it. We want to come over and get the data. But I want to do one thing first. I want to shut all the rest of the data off for right now. I want to focus on the signal, which is yellow, and the 5 volts, which is on channel 2. So we can see we've got 5 volts. We've got our sensor pressure down here. Now that's interesting. Look at that, went all the way to 5 volts. So that's an open circuit. That would show too much, not too little. We weren't having a code that said it was too much voltage. We had one that said we're low. That's really interesting. It's like the ground or something is opening on that circuit, because that ground going open would get me 5 volts. So maybe we have some kind of a connection problem. And we've got something going on in between where we're grounding here too, because that should just be a smooth, good line. Let's rev it. So let's drive it and see what we got. We'll floor it. It's going open. I'm losing a ground there. That for surely isn't what I anticipated. I thought it would be low. It's going high, like we've got a ground. But look at right here. So let's stop that really quick. We'll go up here and we're going to take a look at this. Okay, so I want to take my zoom and I want to look right here is what I'm interested in. Do you see how I've got some noise here? And then I go almost to a ground plane? That's like grounding somehow. So I'm going open and I'm grounding. Now that's what I expected from this. Now we got some railroad tracks right here. So let's just go across the railroad tracks and see if maybe I have a wiring, a connection problem. There's something really different with this car. It wasn't what I expected. It's going high, not low. So here we've got a rough hit with the railroad. And look at it totally when we hit that railroad track, look at what happened. Okay, so let's look at this. So we'll take our zoom window. We can see that we came up to 5 volts. Now the only way that circuit can have 5 volts is if I lost my ground. But down here, once again, I have something and then I come down and I'm at a ground plane. Okay guys, so right now I think the problem is the sensor, the connector, or it's the sensor. So let's go back and let's wiggle the wires and that sensor and see what we can figure out with the scope on it. If I've got the scope on it, I should be able to see what fails. Okay guys, I'm off the test drive. On the test drive we saw we either have a problem with the wiring or the sensor. So I've pulled the intake up as you can see here, and I've got access to the high pressure fuel sensor right here. I've got the red end of the 5 volts, the yellow is the signal, and the green is the ground. Those are displayed right here. Now I want to come over here and we want to graph those. The other thing I noticed is this alternator looks new, like they might have damaged the wire or the sensors putting this in. So we just want to make sure, and that might not have anything to do with it, I don't know. So what I want to do now is I want to just move all the wires around. And we'll see it on the scope if it fails. Right there, we got something going on right there with that trace, and I'm bending the wire down here. So that's some kind of a connection problem. That's in the wiring. And just so I can show you, do you see how that's coming up? That's not my connection coming loose, because if my connector comes loose, it'll drop. Do you see how it dropped? So if my back probe was coming loose, it'd be going down, but that's going up. That's actually something wrong with the wiring harness here. I have a problem with that harness right there. When I move it, I can make that fail. Okay, so that's cool. This car has a wiring problem. So we're going to need to get into the wiring and see where the problem is. But the small harness that comes off of that sensor down here right behind that alternator has a problem.
What?
So
no, wait.
Let me get the wiring fixed on this car and then we'll put it back together and take it for a drive. Okay, so I've stripped back this harness. This is a sensor. And I've stripped this back and you can see right in here where the wire is flattened, like they pried on it or it got caught under the alternator. And when I bend that wire right there, I can get it to fail. There it failed right there. There it failed. I'm just moving it right where that crimp is on there. See it failing on my scope? So that's where the wire is bad. So now I need to fix that wire and then we'll be ready to go for a test drive. Okay guys, I got the wiring harness all fixed and I put the intake back on. There were two problems in the wiring harness. We had to fix both. They appear to look from the alternator. Either it got crunched when they put the alternator down or someone pried on it, but that damaged the wiring harness. So now the wiring harness is fixed, and I also did one other thing. He had this used computer put on here and I took it off and I put the first computer back in the car. When you put a used computer on, I could be chasing my tail because I have another problem. So I always like to put the original part back on. There's nothing wrong with the computer. That isn't what's wrong with this car. But now that we've fixed the wiring harness and I've got the scope connected, channel 1 is the signal for the high pressure sensor, green is the ground to the high pressure sensor, and red is the 5-volt signal for the high pressure sensor. And then I added channel white and blue, which is on the fuel pump, the high pressure regulator control system. So those are the signals I want to look at now. So let's go ahead and take this for a test drive and see what's going on with this vehicle. Okay, now that we have the wiring harness fixed, we need to go test this car to see what's going to happen. So I've got the scan tool going. This is the fuel pressure, short term, long term, and this is lambda. We'll come over here and let's get some data here. Okay, so the blue and white go to the fuel pressure regulator. We're going to shut those off for right now. And then we've got the red's 5 volts, the yellow is my signal, and the green is the ground. So let's see what we got now. Okay, so the signal definitely looks way better because it's not going up to 5 volts like it was before. Right away, before when we started to drive it, we were seeing it going to 5 volts. But let's get in it hard. Okay, it pulled really good that time and it stayed high. Here's those railroad tracks. Let's go ahead and hit these again and see what we get this time. Yeah, totally different waveform. Let's get in it again hard. Okay, there it is. It totally shut off. So we pulled up, but the signal is working correctly. So let's get that stopped, and let's go down here and get into the scan data. We'll hold that data. Okay, so we can see where we started to pull up and then it drops. And we can see the lambda right here. And the lambda stepped up and it went 2 to 2, so it definitely shows it's lean. We got some trim over here, and again we've got lean here. So it came up and it's lean. So the O2 is saying it's lean and I'm trying to correct it. That makes me think that we really are going lean. We have some problem with this where we're losing fuel pressure. So we're losing fuel pressure. The difference is now this signal is correct. And we can see the signal failed. Okay, now we're going to turn these guys back on. We're going to come right in here. This is where we lost pressure. So here's my volts. The yellow is. So here we've got the pressure, and we can see that these are wide here. We can see that these are real wide. And that's trying to command the pump to make more pressure, but it just can't. So the computer is doing what it should do. The computer is trying to make it work better. But the computer's trying to command more pressure, but we can see that we're just totally on the bottom. And when we go back out here, and we go over here where we had, over here, we can see that these aren't on as far. These are on for a shorter period of time. As the plunger is coming up, this turns on earlier to try to get more fuel if we need it, if we need more pressure. Now here we can see we're losing pressure here, and we can start to see how much wider these are coming on. The computer is trying to correct it, but it can't. I think we have a pressure problem like the supply isn't supplying the high pressure pump. It feels like that. I floor it and it pulls, and then it runs out of fuel. It feels just like I'm running out of fuel, like I've got something wrong with the primary side. So what I want to do is I want to get an amp clamp and I want to put it on the wire that feeds the pump and see what we got. But this computer is doing what it should do. It's commanding and it's trying to fix the problem. I can clearly see that it's working. Is what we have a problem with is we've just got a problem where we're just losing fuel pressure. And if the primary system, if the lift pump can't supply the high pressure pump, we would lose pressure just like this. So I know they've done a lot of work on this car, but I think that the problem is somehow it's in the pressure feed. So I want to go get that set up to check the fuel pressure on the low side and an amp clamp, and we'll try to figure out what's going on with this car. In order to check the fuel pressure falling away or not, I want to make sure we catch it. So I took the fuel line off of the high pressure pump, the feed in, this is from the lift pump, and I've teed in and I have a pressure transducer, and this is on blue, number 4, channel 4. Then I pulled the fuse for the fuel pump, that's the lift pump, and I've got an amp clamp on that, and that's orange, channel 7. Then I've got injectors on brown and purple, those are the injectors. So now let's go ahead and take this for a drive and see what's going on with this vehicle. Okay, because I put a pressure transducer on, I needed to zero it before I connected it to the pressure, otherwise you won't zero it correctly. So I came in and I picked the pressure transducer and then I zeroed it, and on 7 I picked the amp clamp and I zeroed it. So now let's get the data and see what we got. Okay, so the blue is our pressure and this is the amp reading. Now something's going on with the blue. Look at how wide it is. So let's take a look at that. So that's dropping pressure. I'm building pressure and dropping pressure. So basically I'm about 60 pounds, but I'm dropping down to about 57 pounds. So every time the injector opens, it's dropping. You can see these injector strikes right here. That's the purple and the brown. Every time the injector opens, I drop that pressure, drop the pressure. So I already have a problem with the feed side, the low feed side. So let's go ahead and drive the car and see what we've got. The other thing I want to do is let's go ahead and get these. I got the scan tool up, so we're going to get that. So this is the fuel pressure from the scan tool. This is short-term trim, long-term trim, and this is my lambda. So we'll be able to see this fail if it's going to fail. Let's go see. Let's take it for a drive and see what we got. So it fails when we're in it hard. It didn't fail. I was in it. Wow, look at the pressure. The low pressure fell totally away. Now, I didn't feel the car cut out, but that low pressure is definitely falling away. So let's get the high pressure to fall away and get the car to cut out, like what we saw before. Yeah, so it's got a low pressure feed problem, there's no question. So we'll need to figure out what's going on with that feed, but first let's just get it to fail. We can see that the low pressure is failing for sure. Come out here where we can get in it a little bit longer. So it pulls up. We lost our pressure there. Right there, it just flat cut out. So I'm going to get back out of it. As soon as I started to pull my foot out of it, I could feel it pick up. So we're going to stop that data. And now we want to come over here and just look at the data really quick. That's where we can see this. So right here you can see the high pressure pump falling right away, and this is the low pressure feed. So this is the blue is the low pressure. I got in it and you can see the pressure just fall away once it starts to use fuel. I got out of it and it pulled back up. So now if we look at this, we can see every time we open an injector the pressure is dropping. Now what that tells me is I have a restriction. Now let's look at the rest of this. What I'm interested really is down here. So this is the amp reading from the pump. So right here I have pressure. We can see that I have about 60 pounds right there. So let's come in and look at the pump speed. So what we're going to look for real quick is we're going to sort of look for a signature. So I've got 1, 2, 3, 4, and the fourth one is low. 1, 2, 3, 4, fourth one is low. That's 1, 2, 3, 4, 5, 6, 7, 8, 9. Now most of the bars I'm used to seeing in commutators, they're about 8. But I'm not going to worry about that because all I'm looking for is the speed change. So it won't really make a difference to me right now how many bars the pump actually has. But the signature tells me that that's it, and basically I'm 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I want to count 9 out on all of them. So what we want to do, we want to pull the calculator out of the... So we want to take this 115, and we want to multiply that by 60. I have about 6,900 RPM. Now that's a little high, but usually I would expect that to be about 5,000 to 6,000 RPM, so it's just a little high, but that's okay. So what I want to do now is we want to go back over here, and I want to look at where this fell, where I didn't have pressure. Now we know that we lost pressure here, so let's go look at that here. And what I want to see is if the pump changed its RPM. Now what we know we used was 9 bars. So we want to use the same. That's 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 9. We have 112. So we're going to take the 112 and we're going to multiply it by 60, and we're going to see that it didn't speed up. That pump, for that, okay, let me explain this, guys. I had here, I'm pushing 60 pounds of pressure, and I dropped down here to just a couple of pounds. So let's get the cursors, and we'll mark this. We'll mark this. So I had 57 and I dropped to basically 0. So I dropped all the way where I don't have any real pressure down here. So the difference is 60 pounds because the difference between cursors 1 and 2 is 60. So I dropped 60 pounds of pressure there. So I dropped it all the way. Now if I'm under a load and I'm pushing a pressure with that pump and my RPM is 69, and when I fall totally away it goes slower to 67, then that pump still is pushing pressure. It didn't see this drop. Otherwise, I would be pushing about 69 over here, and over here I'd be pushing 8,000 to 9,000 RPM when I lost the load. I'd have no load because the pump's not pushing to push that pressure. It's pushing against nothing because it lost the pressure. But the pump still has the pressure against it because it didn't speed up. It didn't go to 8,000 RPM. That proves the pump is good. This car, guys, this car has a restriction somewhere in the line. There's some restriction, some way this is restricted. So when I get it under load and I need more fuel, the fuel is just dropping off because it can't keep up with the volume. It can't keep up with the volumes because it's restricted. Now I know it's restricted because the RPM of the pump did not change. And to go from 60 pounds to 0, that pump is going to take off. It's going to be turning 8,000 to 9,000 RPM. So right here, it did not do that. So if it didn't do that, then the pump is still seeing the pressure against it. That's also why we see the other side of this. So we see over here, so let's come back over here. we can see where every time, let's come back out, come back over here. Now the pressure is up here, and every time the injector opens I drop, and then the injector opened and I drop. These are injectors, and you can see that on each one of these where the injector opened, the injector fires, it dropped the fuel pressure. Well, that's because it's restricted, and now we've proved it's restricted. We've proved it because the pump didn't change its speed, and the pump would have to change its speed unless it's restricted. So this is showing me I've got a restriction, and then I'm going to prove it with an amp clamp. So if you went and put a new pump in this, you're not going to fix this car because that pump is good. This has some other problem. There's some kind of restriction in the line. From the pump to the engine, there's a restriction. So that's what I see here, guys. And that also backs up the data that we first got when we first drove the car with a scan tool. We were losing fuel pressure. The biggest problem is you can't tell what's happening with the scan tool. You couldn't even see that the wires were broken and grounding. You didn't see that till you got a scope on it. The scan tool just showed one nice curve that dropped. Till you put a scope on, you can't see all this other stuff. So I would have never have known the wire was bad. And now I know that I've got a restriction, so putting a pump in the car is not going to fix this problem. The pump is fine. There's something wrong with the line. The feed line somehow is restricted. So we need to go get this car up on a lift and make sure that what is going on with that line. So we'll go back to the shop, and we need to try to find where the restriction is. So we're going to go back over to the shop and talk to the owner and see if I can get a lift to see if I can get it up to look at the line. Find out what all was done to the car too. I want to know if they put a pump in. Maybe when they put a pump in for this problem, they kink the hose that goes to the pump in the tank. That would be a possibility too, very possible. I finally got a bay and a lift for this little Kia. We got it up. I've been thinking about how to best test this car. Now this shop is called the other shop that brought this. That shop is working on this car from another shop. So now this car has been repaired now for quite some time. They've had 2 high pressure pumps in this vehicle, and they've had 2 lift pumps in this vehicle. Whole lift pump assemblies have been replaced. So I really don't want to pull that because it's a waste of my time. So I'm going to feed the fuel out of the pump into a measuring device so we can see how much fuel is flowing out of the pump. And then I've got this line up here loose, and we're going to plug that onto the pump, and we're going to see how much comes out up here so we can try to figure out where this restriction is. So let's go ahead and take a look at what I've got set up here. Okay guys, let me show you what I set up to test this vehicle with. This is the second new module that's been in that car, so I don't want to take it out because it doesn't have a problem. I found the power wire, and I'm going to feed power directly to the pump, and I took the line that goes up to the engine and I pulled it off of the module. Now I'm going to feed the fuel directly into a measuring apparatus. So let's go ahead and so we're flowing gasoline. Now I've already timed this, and I get 2,750 milliliters in 1 minute. When you do the math, that's about 43 gallons in an hour. That's more than enough to run this little engine. So as you can see, I have a really good flow. Now, so what I want to do is I'm going to put this line back on here, and we're going to go test it up at the engine. So let's go ahead and do that. Okay guys, so I pulled this hose off of the high pressure pump. This is the lift pump. It goes just to the lift pump underneath the car up to here. Go ahead and put power on it, okay? Look at that. That's all the fuel that's coming out. I wouldn't even think that could run a car, and this car actually ran pretty good. So this is a lesson to me. I wouldn't think that that little amount of fuel would run this car. But this car actually ran pretty good until you got in it hard. So that's how little fuel you really need to run a 4-cylinder car. So I learned something on this car. I wouldn't have thought that would even run the car. Okay, that's good. Shut it off. So that's full fuel. Look, that's all that came out in that time. On the back, we almost filled this jar. So the hose is definitely restricted. Now, I've raised it up on the lift and I pulled all the plastic covers off underneath the car that covers this line. This line is good all the way back. The only thing I can see is I don't think this is stock. I think somebody put a connector fit in here and this is a fix. I think this is where my restriction is, but I'm not sure. But the one thing we're positive of is it's good out of the pump module and it's bad out of this line. Somewhere in this line there's a restriction. I think this is where it is. That's the only thing I can see that's different on the line anywhere along. And I don't think that this is stock. I think somebody did that. Okay guys, so get this. This car has had 2 high pressure pumps and it's had 2 lift module, two pump modules in the tank installed, and it still has this problem. This is 2 shops away from this shop. The first shop brought it to a shop and that shop brought it to this shop because they know this guy is really good and he can fix cars. If you follow a logical, thought out process and you use scopes and you don't rely on scan tools, you too will have good troubleshooting in your shop. Okay guys, this is such an important concept, what we're doing on this vehicle, to where if the fuel pressure falls, the pump has to go faster. I wanted to demonstrate this, so I set up an experiment. I have a fuel pump out of a 2016 Kia Rio, just like the vehicle we're working on. I have fuel in this containment, which is like the fuel tank. And then I've got a pressure transducer, a 300-pound pressure transducer on channel 3. That's right here. I've already set it up, 300 pounds, and I've zeroed it. And on channel 1, yellow, I have an amp clamp and I've zeroed it. So now we're going to do this to where we can see it. So I want to get my scope up. Let's get some data. We're going to go ahead and we're going to feed this power to the pump. So now we can see where we have pressure. The pressure came up. This is the amperage down here. Now I want to free the pressure, so we're going to take the restriction out so we can see our pressure fell there. Okay, so what I want to do now is I want to take my zoom window and we want to come down here. We have pressure right here, so I want to look right in here. Now we want to find our signature humps. Count them. 1, 2, 3, 4, 5, 6, 7, 8. Now most of the pumps that we work on cars have 8 commutators. Not all of them, but a good portion. Now you need to go to 9 to get back to where you started. Because you go 8 bars, but you got to go 1 more to get back to where you started. That means the pump took 1 360-degree rotation. So now we look right here, and we can see we have 98 hertz. The 98 hertz is right down here. Now we need to get the calculator up. So now I'm going to take 98 hertz, and we're going to multiply it by 60. That means that pump is turning 5,800 RPM. Now we want to do something else. We want to go over here where we drop the pressure. We know we don't have pressure right here. So we want to do the same thing. So basically we have 1, 2, 3, 4, 5, 6, 7. That's 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And now we have 126. So now we're going to change this. Put 126 times 60, and the pump sped up a few thousand RPM. Now it's turning 7,560 RPM. If the pump doesn't speed up, the pump load is still present. As soon as you lose pressure, the pump's going to speed up. Now let me explain how each one of these pulls is made. So this is the commutation system on a PM motor, permanent magnet. So I have a permanent magnet on each side, and I have a brush. And current comes in to one brush and to the other. So one's going to have power, and then it's going to have a ground, and current's going to loop through this winding. And as current flows through the winding, it has a magnetic field. Now this magnetic field is working against this magnetic field, and that's going to make this rotate. And as it rotates, it's going to go up onto the next commutation, and then the next commutation. In between each one of these commutators is an insulator. So we're going to roll across that insulator to the next commutation bar. Now, if we didn't have commutation bars, the signal would want to go negative and positive. This would be an AC waveform, but this is a DC style pump. The commutation bars are cutting it off at the top, so they're cutting off the tops. So each one of these is the pull from each commutation bar. What you're seeing right here is what we're really seeing back over here. So each one of these, this is the current going through the winding. This is where we went across the insulation, current pull, the next current. So we can check each winding, therefore I can check the speed. So as we can see right now, when you lose pressure, the speed of the pump has to increase. Now the overall speed of the pump is going to be set by the back EMF. Back EMF is referring to motors generally. Counter EMF is something that refers to like injectors. That's where the current's flowing through a winding, and as the current flows through the winding, a magnetic field comes out of the wire. As that magnetic field crosses the windings, it induces voltage into those windings. Now that induced voltage that is freed in the winding gives opposition to the current flow. So the faster the pump turns, the more back EMF is created. Back EMF is caused by an external source, such as the permanent magnet. Counter EMF is like an injector where the winding itself is creating those freed electrons, but it doesn't have to do with external magnets. So that's counter EMF. Motors have back EMF. The faster the motor goes, the more current is going to drop. So if you notice right here, I have a high current, and if you notice right here, this is the inrush to the motor. This is a really good way to check to see if I have resistance, how high the current first comes up. If there's resistance in the circuit, I'll see it here. Then we come down and we start to have a current pull. When the pressure drops, we drop current with the pressure because the speed of the pump increased. The faster the pump turns, the more back EMF happens, or the more magnetic fields are building and collapsing across the windings, and that gives me an impedance to the current flow through the circuit. Now, the overall speed of the pump is generally set by the back EMF. It's a product of how this is made. So how pumps are made sets the overall maximum speed that I can get. A motor will start to turn at a speed, and then it's going to have a hard time turning faster than that unless we do something to alter the signals that go into the motor. That would be like EV cars do. You can actually counter some of the back EMF by changing the timing when we're applying the current in the circuits. But in a PM motor like this, we don't do that. So the faster the motor spins, the more back EMF and the lower the current, and we can see the current drop right here. And that's what's happening. It's indicating the pump sped up. And if the pump speeds up, it's because the pressure dropped off. The pump's under a load and it's pushing against that pressure, and then the pressure falls away. The pump takes off because there's no load on it, and now it's just running at its maximum RPM. Some pumps will be 8,000 or 9,000. Some pumps like this is going to be 75, 78, 8, somewhere in there. Again, that's a product of how the pump is made. Each motor has a maximum RPM value, and it's built into the pump the way it's made. So that's a really good trick because this really helps. I want to show you one other trick. In this blue waveform right down here, this is my ground. Now do you see how in the ground that's the same as that current? So let me explain why I would want to do this. A lot of times this pump is right up against the body of the car and the fuel tank is collapsed. It's very hard to get this awkward amp clamp up and get around a wire. It's much easier to get into the powers and grounds. What I want to show you is that ground right there is proportional to the current. So let's go up just a couple of steps here. Now, do you see how each ripple in the ground is the same as the current going? Because the current is making an opposition. That motor is opposing the current flow. So I can see that in a voltage drop on the ground. So if you're in a power or ground, you can see these as long as you have a good scope. Our scopes all are 16 bits of resolution. So we can see really small voltages like this really easily. And it's for doing this kind of work. So if I'm on powers and grounds, I can see this. And if I wanted to make that signal just a little bit bigger, we can do that too. We'll come over here and we'll put a ×10 right here on the blue. And then we're going to go ahead and we're going to multiply it. Now is what we've got is that blue one just got bigger, and it will be easier for us to see that it's mirroring that current. So what I want to show you is I can look at a power or ground when I can't get a current clamp on the circuit, and I can't tell you the overall current that's being pulled, but I can tell you the speed of the pump. So I can see if the pump changed its speed or it's cavitating. This is a really great trick. Be aware that if you're on the powers or grounds, you too can use that to count out your pulses and to see how fast the pump is turning. So it's just another really great trick that I use a lot, because sometimes the current clamps are really hard to get down under the car on a circuit like this. And many times if you use a current clamp up on a fuse, the circuit can power other components. And so it gets you confused. If I'm always at the wire that powers the pump or grounds the pump, I'm always safer to do this kind of work. So now I can show you that the pump should have sped up. Now on the car we're working on, we saw the pump slow down when I dropped pressure, not speed up. But now that we understand some basic principles, we know that it has to be restricted, because if the pump doesn't take off, the pump is still seeing the same pressure. It's not changing pressure because it's pushing against a restriction. On this vehicle, when they fixed the line, when they were heating it, they melted the plastic line together, and that's what was wrong with this. At the end of the line, it looks like they've done a fix. They replaced the line, and I went down and got the line and I cut it open, and you can see when they heated it to shrink it, they got the plastic too hot and it melted. So if you're doing a fix like that, be very careful with how hot you get the plastic line, because you can actually melt the line together and it will give you a restriction. That was what was wrong on this vehicle. It's the line restriction from being melted together. So hopefully this is a better analogy so you really understand what I'm talking about. The pump, if the pressure drops, the pump has to go faster. If the pump doesn't go faster, then it's still seeing the load on it. The load didn't change. The pressure at the pump never changes. But the pressure at the engine does, and that's what we see where this is falling away and our power falls away. Thank you guys.